So my name is Vadym. I'm Ukrainian native. Serverless is one of my passions, and I'm AWS community builder since practically the beginning of the program. I blog a lot, I tweet a lot, so if you would like to get in touch, you can find me. I have quite a unique surname. So this talk was prepared with my colleague Firdavs, who is in the team, who has implemented the storage solution. So also kudos, huge kudos to him or to the team. And the team name who implemented this is Serverless. So there's quite a relation. Yeah, and we're in Germany, that's why kind of this one. So just to set the stage what we are doing and why the photos are so important, we have developed, that's our core business, the solution for designing and purchasing of the photo products. And these are calendars, photo books, prints, posters, so everywhere where you can simply print the photo. It can be mug, everything. So that's why it's basically, the photos are at our core, and we need to deal with that efficiently. And we are 100% Fujifilm company, so we were acquired 15 years ago, and just provided solution for basically wholesale solutions, so white labels. So we just designed the solution, and our customers, we customize this for them, and they are just in this B2C business, or B2B, business to business. So this is an agenda. I just wanted to briefly talk how we got there, how was our journey in AWS anyway, and then we will be talking about motivation behind why we needed to re-implement even this storage, what were the reasons and why we choose serverless, and also we'll be talking about architectures and especially event-driven patterns that we applied in our solutions, and briefly we'll be talking about challenges and lessons learned. It's just the topic on itself. So our architecture looked back until 2017 quite, I would say, classic. We were in the data center, and even in several regions, we had our own customers. After the acquisition by Fuji had their own customers, especially in Asia. So the same product have been basically deployed in different data centers across the world. And it was classic stuff. We had this Java Tomcat backend, we have central database, and we have a huge central storage for all things that we do. Normal, everybody would develop it like we did, because we started 2004, and I'm 18 years in the company, so nothing wrong with that, but that was kind of the situation that we were across the globe, but in the data center there have been different vendors. So we didn't even control. In the Fuji data center in Japan, that was their hardware, and in Europe it was our hardware, so we could have a 5 load balancer and Nginx in Japan, so complete this very difficult situation, how to deploy efficiently the same stuff there. So lots of challenges, and we wanted to go globally. We were, for example, not in the US and all that stuff, so we thought also just how to modernize it. We are highly in the peak business, so in December during the Christmas, people buy photo book of the year, so we also suffered from that kind of architecture, to be honest, and there have been thoughts how just to deal with that. So we choose AWS. It was the most mature cloud provider anyway, and it still is. And we just took 4 years basically to migrate all the application to standardize things. So the ability to go globally, we just used infrastructure as a code for everything, no more patches, and there have been lots of patches. And nobody knew the state of the application, and we provided independent production near staging and test environments. It was a huge headache in the data center because there were no test environments. So the live load balancer was used for staging purposes, and if you do just a stress test, then you could impact live applications. It was easy doable in AWS simply to separate environments, and just it enabled us to safely test. But what we also achieved during the migration, we just split most important things apart. It was basically lift and shift with a lot of automation, but we also introduced some independent services here. So at least we could change a bit the logic of our storage, which was monolithic. Now we could separate the stuff for personal images. We are not producing anything, so we need to ship the stuff to the lab, which will produce. So for this kind of storage where the lab will be kind of pooling the orders, we just push that stuff on S3, And we have static images like product images or videos, how to design the product, and each product like photobooks, you have high quality images. It doesn't have anything to do with the uploaded images that you use for design. So we could separate it. We just put CloudFront and we put a lot of auto-scaling policies based on the stuff. So it was really a huge step that we did with AWS and with everything that has been enabled, basically, with all this stuff that have been separated. And of course, also speed of delivery increased because we just had some, at least, core services. But there were some technical challenges remained. It hasn't been a huge problem, but anyway, our web application, it has been still, even on EC2, it was basically Tomcat server. We bundled nearly everything together. Front-end and back-end was bundled together still. So our builders or editors, how to design the product, have been deployed with the back-end together. And the back-end contained all the services bundled together still. So this is the photo book creation, safe load of the product, user management, payment, ordering, external integrations. Everything has been basically in this monolithic application. And yeah, this central storage, even for personal images, it could become, because of the stability and how we use elastic file system, it's rare the case, but at least there can be the situation that if this elastic file system suffers from some degradation, then it propagates to all services and puts them down, basically. And it was it could have been scalability issue. We could mitigate it by provisioning all that stuff, but we were aware that we may run into the problems. And we still missed clearly defined API, especially for the storage solution, low stability, so no clear ownership because of the monolith, and the storage is key for us. But the bigger problem from the product and strategical point of view was that I just said that all backend services have been put together, and we simply realized that back in the days we implemented the e-commerce system on our own. All this purchasing stuff, product catalog, we have implemented this starting from 2004 and put everything together. And our business asks just, can you integrate Shopify? Can you integrate Magento, which is now Adobe Cloud? And we couldn't, because the many things that were bundled together are generic. Even the storage, how we deal with pictures, is generic, but it was so much tied to all the self-written e-commerce system that it wasn't simply possible without refactoring. And this is something that basically was a driver for us to say, okay, we should split even more apart, and the storage is really essential, so that the storage can be reused for Shopify, Magento, and all that stuff. So yeah, that was around several years ago. So we started to experiment with serverless, to be honest, 1 year after we started the migration of our data centers, which we finished 2021 completely. So we don't have any data centers, but we started to experiment with serverless 2018. So we are now in 6th year. And for us, we just saw so many benefits we could deliver without all this infrastructure stuff and so on. So I think you can achieve the same independent of technology. You can do this with EC2 instances, you do it with containers, you can do it with Kubernetes. But for us, it was this cultural stuff that the people simply saw the value of serverless, and back 6 years ago, they have been missing features a lot comparing to now, but we started to dig in, so the people started to build experience that just spread in the company. Yeah, so that was more cultural thing, and even if we are a part of the Fujifilm group, we were allowed to decide on technology on our own, which is cool. Yeah, so we were not afraid of some cloud lock-ins and all that stuff. So this is how it just developed. I'm not the only person who is talking in the conferences and all that stuff. So we have a lot of people blogging about this, and so this was basically cultural thing behind why we choose serverless, because we have had some experiences with that anyway. So now we will be talking about storage. I will show you some diagrams, and there they have some abbreviations. That's image storage solution. We call it internally consumer file storage, or shortened CFS or CFS. This is the same. So this is all about dealing with pictures that people use to design their products. So now let's look into the architecture, and it's only the brief one of the solution that we implemented. And maybe the first one is just seems scared, and I even hide it, some Lambda functions. But this remembers me, so on the day as Jan Kui presented serverless the first day, so people saw how you can manage that. But basically, if you will look further, there are so many different APIs. So it's just not, I will dig deeper if I will be talking about event-driven solutions there. So there are so many different parts of that file API, project ordering, config support. So each individual API is not looking that scary if you just simply zoom in there. And yeah, if we were talking about event-driven architectures, then obviously there will be some individual services or combinations of SQS, SNS, EventBridge, Kinesis, DynamoDB streams, CloudWatch, EventBridge scheduler. And if you look at least into this diagram, you see we kind of have it all. We have queues. Okay, it's probably not possible to implement something now without queues. We have SNS. We have EventBridge here. We have DynamoDB streams. And we have here scheduled events. And we also have Kinesis, but I will be showing the use case with log files, how we are using it. So basically, we are using it not because it's cool to use everything and present in the conference, but it has its usage. Yeah, these are different services for the different purposes. So maybe you will be asking, what's so difficult? Yeah, you just put some images on the products you upload, and why is that complicated? Yeah, it's complicated because there are so many different workflows. The simplest one is just to upload picture. Normally, you just select it on your computer or on your phone locally, and that's okay. It's normal upload. But we have also something called mobile upload, where you can simply kind of scan QR code, send it over to your friends, and there will be URL, and they can upload this kind of to your storage. If you if you were with your family in the vacation and your grandmother has photos, she can upload it to your storage, and you can kind of collect that stuff. But of course, storage costs money, so we have a mobile upload, but also on top that we charge, we have long-term storage. By default, the storage will be kind of expiring after the session of the user has expired. With the long-term, you can save it up to whatever day the customer is willing to pay. So our customer, not the end customer. So we configure this. We have Safe Project. You can imagine the working on the photo book is not one day work. My wife is working the whole December. It just drives me crazy. The whole evenings to just collect everything, what we showed as the photos for 1 year. And of course, you would like to save in between and then simply continue. So we have Safe Project. We have, of course, cart items. So if you just designed it, you would like to purchase, you put it into the cart. And we have our internal carts, but we have solutions that we develop with our customers. There we have external carts. Like we have customers that not only have photo business, but they can also sell furniture, flowers, and whatever, and they would like just with a single sign-on that the customers can put everything in one basket, and everything that goes via our solution will go to us, and all the stuff. So we have some APIs for that as well. Yeah, if you finish the order, you have ordered cart item, so that is the order, and we have a lot of expirations. Yeah, so you can delete the stuff, the photos, images, products, saved projects, manually if you don't like them, but we have, of course, automated expirations because we don't save anything forever. Like Safe Projects, they also, there is a configuration to be expired automatically with notifications and all that stuff, and we have lots of cleanups. So lots of workflow, lots of completely different workflows, and that's why simply we need so many different stuff. So now let's talk about, I will only dive in some kind of extracts of the diagrams about event-driven solutions that we have, so that, because it's just event-driven architectures here. So queues, yeah, really everywhere. Yeah, and it's also in our case, I will show you some use cases. And the first one is so trivial. Yeah, everybody, if you just see the examples how somebody can use queues, you will always have this example with generate thumbnail from the picture. It's also what also appeared on AWS blog post as an example how you use queues. And yes, we're using it the same way. So that basically as a kind of the picture is uploaded to S3, we'll have then S3 create object event, and we do something asynchronously that simply are feasible to be done asynchronously. And the thumbnail creation is nothing that will be accessed immediately. So it will be accessed if you will access the project once again, which will happen not in the same second. So we are just doing it also asynchronously, and we are also setting some other states, and with thumbnail creation, we can also decide what size of the picture so what thumbnail size would we like to create. It depends whether you're in the web, on the notebook, or on mobile phone. Then there are different requirements. So it's a bit more logic, but basically that's very, very natural for us just to create the stuff. Of course, if you very quickly would like to access the project, it may be that it takes a bit of seconds, then the thumbnail will be generated and displayed, but in 99.9% the cases, that's totally fine. So we have here another queue. We call it handle file usage queue. That's a very long name. The thing here is that we have here events that save project containing images and files were deleted. So either by the user actively or expired after a certain time. So we have a quite complex logic, because you can use the same image in different kind of projects. You can create multiple projects with the same image, and we don't always copy the stuff, so we reference the stuff. So what's very easy in the front end, simply to delete the project, is sometimes very difficult technically to implement, because we need to see if the existing, so each individual picture has references in order to delete the picture itself, because it's not copied, it's shared. And this is why we are doing that asynchronously. We put this into the queue, and then we have processes that run. There's even stage asynchronous processes, so we simply run via DynamoDB. DynamoDB is kind of handling that references, and if we see that the picture is not referenced anymore, we mark it as not in use, and then we will see that scheduled events that will really remove it basically on the storage. Also very powerful and kind of very natural, and saves lots of times, because this is also kind of time-consuming task. So here we'll see the combined patterns. So now we see here even SQS FIFO with EventBridge and Lambda. So what's the use case? Here I just only show you this FIFO queue. We have some central application. I'll be talking about it later, just to put events. So this queue is kind of for the user states. So what we are doing this, we would like just to see if the user logs in and logs out and several other events. It's the natural that it should be FIFO queue, because it's not very lucky if we will receive logout event before login event, because our system can then a bit go in madness if the sequence will be not okay. So this is one of the example of the FIFO queue. And in this FIFO queue, then simply we have Lambda function pulling from that, and then we have EventBridge in the middle, just that goes through different targets and simply sees what needs to be done. So for example, if you log out, what needs to be done is simply just that you remove the stuff that you probably not ordered. For example, you could put something into the cart, but you don't order. And we have the logic, if you log out and you have such a state, we remove all the projects and all the pictures, because they have only the life cycle kind of your session. We are not allowed to that it stays, because if you are in the internet cafe, somebody can just log in and see some pictures and use that stuff. So we are quite cautious here, and we have here kind of this logic on the project level, so that we remove all the projects or cart items in that sense, but we also remove files uploaded via mobile upload that are not stored on the long-term version. So if you upload only files, you can use it only within the session, or you are allowed then to store it for a longer time if the customer kind of is willing to pay. So lots of cleanup work here, very powerful pattern. The question that may arise here is why we choose EventBridge, for example, over SNS. And to be honest, we can do both. In that case, they are quite close services. And in this case, we have here two downstream consumers, these two Lambda functions going through project and files. The same can be done via SNS, but we personally prefer to use EventBridge in case these are events going on. So there is event, check the project, there is an event, check the files. and it kind of sounds more natural. We use SNS for basically more notification-based stuff. Even if EventBridge is a bit more expensive, but it allows us to define the schema and all that stuff. So we're willing just to pay a bit more, but the same scenario will be also working with SNS. Yeah, now we will come to other stuff. You see here we are using DynamoDB streams. So what are the requirements? We have the requirements, I call it personally change log pattern. So there are different APIs dealing with that. So the first one is this config API. So how the customer account, the partner account is configured, we have the requirement that we store the change log. So all the changes needs to be stored because somebody can say, I haven't configured it like this. And one of the important configuration can be, for example, how long are this saved project are allowed to be stored. Yeah, if 16 days and so on, if you just change it to 1 day, then all the projects will be gone of the customers. They will receive notification and the same day they will be gone. They cannot save it. It's a lot of work that can be kind of lost. So that's why we simply need to store all the changes, who has done what and when. And this is the one pattern that we use, and it's very easy. We store the configuration, then we use DynamoDB stream just to process that, and we have Lambda function that processes that and stores that additionally in this change log table. So we have the whole history of who has done what. The same is here, this support API. So what's the reason for support API? Imagine somebody saved the project, worked weeks on that, and then he tries to open it and there is an error on our side. What error is possible? Something has changed during, we made an error and the person cannot simply open it. We are not simply allowed to access that project. We have the support API. For that, this is our internal API. We have support team who can go and say, I would like just to switch the owner kind of to me to investigate that. Yeah, we can even copy that so we don't damage it, so that our customer support team simply can own the project, open it, they can go into the logs and they can talk to developers, and then we can look how to fix it, and when they have fixed it, then maybe we can apply the fix to this project if it's something on the front-end side and on the back-end side. And also this customer support, accessing the images of the foreign projects is GDPR issue. So we need to save who has accessed what, and even, yeah, we also need to just assign the ticket so the customer, so our partner asks us to investigate the problem for its end customer. So this is the same requirement here. So the same logic is here. We have kind of asynchronous processing table. So if somebody in the support API, for example, does change the user, the owner of the project, that goes the whole log, the change log will go via DynamoDB streams, will be processed by the Lambda function and stored in this change log table. The same table for two different cases. We have here a single table design. So Alex Debris, from expert in DynamoDB, is not here, but he will love that, hearing about single table design. So these are kind of that use cases that we heavily use now here, DynamoDB streams, and it's really powerful. And what's important, we only kind of listen to events that are really important to be stored as a change log. So there are certain changes that they are not interested in, they are not relevant, you cannot do too much damage. So we have kind of the logic that we filter out what can be now kind of sent via DynamoDB streams to Lambda. Yeah, this is what I explained. Yeah, and of course, yeah, what we have here, we have lots of scheduled events. So once again, all these cleanup jobs, where we delete the save project, is all done one time per day or several times per day. For that, we use heavily scheduled events. You can use the EventBridge scheduler for this as well. This is the same. This is more or less CloudWatch rule that can be triggered with a certain pattern and a certain point in time. And then we have here different use cases. So the first one is finding expired save project, card item, mobile uploads, what that has been marked that needs to be deleted, and that will be deleted via on the storage. This is the first pattern. And you here we see that we send a notification because we need just to send notification via email to the customers. We do it in stage environment, like you have 5 days, otherwise the project will be deleted. And we have some logic if you just change the project and the expiration period starts from the beginning. Yeah, this is how we work with that, and then they can decide would they like to continue to work, the purchase, or even just they have already purchased and are agreed that it can be deleted. And what we also have here, we need to calculate the, the invoice. So how much storage has been used for what customers, for all different projects. And you see here also scheduled account. And we have here, once again, we have here Lambda, which splits the stuff, and we calculate this matrix, simply calculate for each customers all that stuff, like how many account project does they have, how on the file matrix. So we have projects that contain files, we have individual mobile upload, long-term storage files. So we calculate with those Lambda functions kind of for all customers, all this storage matrix. We publish this via Grafana, and then this can be converted kind of to the project management. They know how much does it cost. It may depend on the customer, and they do it. So also very powerful. And once again, this is the same. We have here EventBridge with multiple targets, very powerful. But the same also could be done also with SNS. It also supports multiple Lambda functions. So also, once again, it's scheduled events. We calculate this 1 time per day, or we delete this stuff. We have one more, a bit complicated situation with sending these emails, because basically the sending of email is not done by the storage. We have our central application which stores, sends all emails possible in our system. And that's why we just simply use the fan-out pattern. We have one more complexity that I didn't tell you. We have still monolithic part of the applications, but which also uses relational database, the EC2 servers, and so on. And we cannot afford to have that system for each individual customer. Some of them are very small. So we group the customers, and we have customer groups that we set up. We have the same infrastructural setup, ILB, EFS, EC2, and Postgres RDS, and we group these customers depending on the logic. So we have very big customers. They're completely alone because that other degradations don't impact them, but we also just put them together. It's also contractual stuff. So once again, if we send here an email notification, first of all, it needs to be decided what customer group needs to process it. So what kind of this individual application needs to receive it. And for that, we use that fan-out pattern where each central system hears to its own queue, which then filters only the messages that are interested. So the queue knows for what customers are stored, are processed via the central service, and they have customer ID in the message, and they only filter their own stuff. So very simple fan-out pattern, but very powerful. And because of that complications, we simply use it very, very frequently. Of course, it needs to be updated if we have new customers, new IDs. It's, of course, job to be done, but basically this needs to be done on this side. The ID will be just transferred via SNS automatically, and then the central system is taking care of sending the emails. There is also work to be done. We have generic templates, and the customer can just decide how each individual template is looking like. So we have here, I think it's one of the last things that I would like to show you in terms of patterns. We have migration API. It's only used for the first time, so the customers had that old storage, and then we decided customer by customer just to migrate them to this new implementation done on the AWS Serverless. And this is kind of a huge process. The old logic had different structures and all that stuff. And we have here kind of this migration API, which kicks in if we start, okay, we'd like to convert this customer to this new consumer file storage customer. And what we do, we just group the user's project into chunks, like 100 projects. We just add some metadata and place this whole stuff with the metadata on S3. It's such a big, because one project can be kind of hundreds of like photobook can contain hundreds of pages, and each page can contain so many pictures. So we all put all this metadata to S3. It's not possible via SQS and all that stuff because the payload is limited on SQS. And then we have here the same stuff. We send event, create event to Lambda function, which then will process this migration of these storages, of these projects, save project in chunks. So this is kind of the example of storage first pattern. So you put something first on the storage to S3, and now you simply asynchronously process that via the queue in batches and all that stuff. So once again, we have here even stage process. It's much more complicated. We migrate all the projects of the customers of end consumers of that customer, but it might be the case that there are so many that the migration takes hours. So what happens if the user, the end user would like just to access the system, and it's in the kind of, his projects are not migrated, and the system is saying, I don't see your project. So we have here on-demand batch mode, where we simply migrate everything normally, but we have this on-demand. So in case the user logs in, we already look into its saved projects, like books and all the stuff, and if we see that something is not migrated, we start migration immediately because we will assume he will go into the saved project and continue something. So we don't wait hours, then it will be his turn. So we have batch mode and on-demand mode. And yeah, once again, it's storage first pattern, very, very mighty. But of course, we needed to deal here. Sometimes we have errors during the migration process because we have customers storing these projects for years, and they are willing to pay it, and the things have changed, so we cannot read that projects that are so old, and there are sometimes errors, and we need to deal with that. Can we migrate, or we don't even have that products are not even available and cannot be printed. So we have here, of course, DLQs and all that stuff. We have internal alerts. It's the people are on the job if the migration is going on, so we can receive also here notifications, look into the stuff and all that stuff, and just to see is that something that it can recover, and with DLQ you can replay the events. But basically what's here also important, we have here also implemented partial batch responses, so that if in the batch things are processed well and there are some project that cannot be processed, so that we don't process the same, don't migrate the same save project once, and you can use this batch write item operation on DynamoDB, where you can also save up to 25 items, so up to 25 migrated projects to the DynamoDB at once, and you will save time, because the most expensive operation when storing to DynamoDB is establishing the connection. Yeah, and if you can batch the things up, then it becomes quicker. But of course, we are dealing here with up to 100 projects, so we just probably have here 4 transactions just in case everything has been migrated. No, that's the last one. I wanted to show how we're using Kinesis. We are not using it with this storage, but we have the central CloudWatch logs. So this storage is implemented on its own AWS account. But of course, we have account for our main applications that I showed you. We have other applications. We have complete self-service for creating the product, which is also completely implemented serverless. So we have different accounts, but we would like to have logs on the same CloudWatch account. So because dealing with pictures is only part of the application. If we have an error, we would like to see the whole flows. The user logged in, the user selected something, the user purchased, and there are different AWS accounts involved. So we are transferring everything to one kind of AWS account where we have central CloudWatch log. And we have kind of this CloudWatch cross-account subscription, so that from our storage account, we can subscribe to that, to the central one. And we first implemented that with Kinesis data stream, but there was even no serverless mode available, but we needed just to provision shards, which was not very pleasant, not very convenient. But then Kinesis data firehose, I think it's now renamed to Amazon data firehose, so no Kinesis in the name, but basically then allowed also the direct integration to Amazon OpenSearch, where we kind of, in the end, the logs will end and we can search for them. So we immediately switch to this Kinesis data firehose. We don't need to provision anything. And then the logs flow via cross-account subscription through Amazon Kinesis data firehouse to Amazon Search, where we can search the whole kind of history, the whole session of the customers. Also very, very powerful pattern. The same can also be done if you are sending emails with Amazon simple email service. You can do basically the same if you would like to have logs. SAS is connected to data firehouse as well. Yeah, this is basically the pattern. So there are much more, but I wanted simply to show you some of them. And what are the kind of lessons learned? It's not quite easy to implement something like this. So I would just only briefly talk about certain things that were important. So the first one, architect with AWS Serverless quotas and technical concepts in mind. Especially if you are dealing with event-driven architectures, you need to understand the differences. When I use SQS, when I use SNS, Kinesis and EventBridge. There are huge differences, but there are also similarities, like SNS and EventBridge have both some common functionality. You need to understand that because you need to select the right tool for the job. This is the first one. The second one, you need to deal with understanding of the service quotas. They are all AWS services have them, but especially with serverless ones, you need to understand they're kind of different. And AWS provides the service calls with the name service quotas. So you can go there, select your service, like API gateway, and then you can look into the quotas. So quotas are constraints, basically, what you can do. And the most important column is it adjustable or not? And these are account and region limits. So we are in AWS region EU Central 1 in Frankfurt, and these are the quotas for that service. You can, if you are in US East 1, you can see different values. And this is very important because if the quota is not adjustable, you need to architect around it. If it's adjustable, you can go to AWS customer support, explain the use case, and they can raise the quota. But you need, in many cases, to explain the situation. And it's important, you can, for some metrics, you need to look just, do you need to change something? They provide you monitoring metrics so you can see this is the concurrent invocations of Lambda. Do I need to raise it? I'm okay or I'm not okay. Yeah, or you can raise the request, so we increased a lot of quotas on our own for API gateway, for Lambda, so that's not a huge problem per se. So, but of course, you need to understand them. I only show you the API gateway quotas, or the most important one. The same will apply for all others. And if I'm talking about the understanding technical concepts, you need to understand the concept of the distributed systems. Like API gateway has its own API gateway token algorithm. You have this throttling of different services, how throttle works. You have rates, you have bursts. They are completely different for Lambda, for DynamoDB. Even the same term will be described differently. And this is hugely important that you understand the stuff, that you will not be surprised by some behavior. And if you have this, you also need to understand how this applies together. For example, by default, if you have API gateway, the maximum number of requests per second for all your APIs is only 10,000. So you can only send 10,000 requests from all your APIs of your region by default. And this is the quota that you probably need to raise very quickly. Otherwise, it might be throttled, but there is this additional burst rate that can be only up to 5,000 that can save you for a very short period of time, and it's even not adjustable. Yeah, so this is something you can raise that even to several hundreds, thousands, but that second one is only for very short burst. And you need to understand how this burst is calculated with token bucket algorithms. And sometimes you need to just set the quotas for different APIs so that the one API doesn't consume all the quota from other APIs. So you can also throttle, kind of say, that's the limit. I don't expect any more. Maybe it's then DDoS attack, but there are other solutions for that. Yeah. Also for API gateway, this timeout, maximum integration timeout is 29 seconds. It's adjustable since several months. Previously, it wasn't adjustable, especially for GenAI cases, so then you are talking to some very slow third parties. You can adjust. There is an asterisk. They can limit your number of concurrent invocations per second for this, yeah, depending what the value you require. If you just require here minutes, we did not need to raise that. I don't know what there will be the reaction, but this is something that's stated clear in the documentation. Also, the payload size with the API gateway is 10 megabytes. Probably you don't need more. You will not upload S3 pictures to S3 through API gateway, you can upload them directly with SDK from the front end. We're using pre-signed URLs, so API gateway is not for that use case anyway. So this is only the one example. So the same is true for Lambdas, for DynamoDB. You need to SQS, you need to understand why the queues are so important or so powerful, because I know only two services at AWS, SNS and SQS, that can scale virtually unlimitedly. This is what the documentation says for SQS, unlimited number of messages per second. Yeah, so it's very difficult to reach something that will break. I could put more than several hundred thousands, and it worked. Yeah, so this is very powerful, but of course you need to also to understand. Then you will be in the asynchronous world, where we are partially have shown you the example, and you need also to understand why, if you need the FIFO, and we needed that one for login and log out, the throughput is much lower for FIFO queues. So you need to think there is a high throughput mode, which is then becomes even more difficult to implement because the ordering is only guaranteed for the group of messages. So read all those concepts, normal queue, FIFO queue, look what's importance of FIFO queue should be kind of an exception, really exception. We needed it one time, but basically the normal queue has unlimited throughput. So the most important also part is, yeah, we have some kind of discussions now about the improvements of services at AWS, but I simply combined just what AWS has done in the recent year with all the quotas and all that stuff. They raised the quotas, enabled the use cases, and you see it has happened quite a lot. For example, Lambda now scales 12 times more quicker. It was implemented for the last reInvent. And even Lambda function can scale even independently. We had previously, I think, 500 additional invocation up to the maximum within 30 seconds. Now you have each 10 seconds, 100 additional concurrent invocation until you reach your account limit. So lots of stuff. Personally, if you like to use Amazon Aurora Serverless v2, now the version 2, the data API has been implemented. DynamoDB introduces configurable maximum throughput for on-demand tables. So the problem was with on-demand, your cost can scale unlimitedly, and you simply can set the max value and say, I would like to balance the cost and performance, because otherwise you will be throttled. Yeah, the same is AWS Lambda supports faster polling from Amazon SQS and all this stuff. And this API gateway integration timeout of 21 seconds has been increased. So to be honest, lots has been done in the last year, and I hope it will continue so that it will unlock new use cases, or you can simply remove your workarounds that have been provided because the limits were a bit lower. So one word of caution, it's also about latency. So I just shown you this metrics, these constraints, these quotas. You also need to understand the latency of all the services, because all these asynchronous things like EventBridge, they introduce some additional latency, and even if it's asynchronous, you need to think, is it enough? Will the performance be enough? I can refer to the talk or investigations of my friend Daniele Frasca. He's talking a lot about this. He's working with a big company, and he has investigated what will happen with EDAs if you use EventBus, SNS, SQS, or even you go through SNS to SQS. So there are kind of latencies. They have been improved. I read that the latency of EventBus, EventBridge has been improved. It's now lower. It's the second improvement this year already. So this might not even be actual, but you need to understand that as well. There are latencies involved, and that's normal stuff. So general architectural decisions. Basically, I showed you DynamoDB as a solution, but with that team, we started first with Aurora Serverless. This was easier for us. We understood relational databases better. The situation was we didn't want to use VPCs with Lambda, what was required, and we kind of wanted to use data API. And we hit exactly one limit with the version 1 that was available back then, number of concurrent requests. And it was not adjustable, only 1,000. So we could not work around this. We talked, Aurora Serverless v2 was released, but there was no data API back then. Supported 2 years ago as we needed to decide. So we could not re-architect. We did not want VPCs, so we switched to DynamoDB. It required a lot of investment and knowledge. DynamoDB is NoSQL, it's different. Yeah, but we did that with another team. We started with DynamoDB. So if you are just now probably having experience in the relational databases, think of it, it's just a bit different, I would say. NoSQLs, but DynamoDB doesn't require VPC. In case you would like to use this read-through cache and write-through cache docs, then you will require to have VPC. Yeah, on the other way, with Aurora Serverless, you need to think, there are also two scenarios, because you will need to think about managing the connections to the database using Lambda, because the number of connections is a factor of the size of the database. Yeah, the bigger the database, relational database, the more connections are possible, but with short-living Lambda function, you can exhaust that. Yeah, so you can use RDS proxy, which requires, with Aurora Serverless, with pure Aurora, it requires VPC as well. You need to put everything into VPC. The cold starts are not the problem anymore, but there's much more infrastructure as code. Security groups needs to be decided, ports enabled, that Lambda is allowed to talk to the database. It's much more code. We didn't want that. With the data API now, which is now supported in the version 2 only for Postgres, it was announced in December last year. There is that option. It was not the case 2 years as we needed to assess that situation. We switched to DynamoDB. Now you have more options thanks to AWS, so you can decide what you do. Yeah, only briefly, of course, there was a talk about, by James, about the observability, really hard, without any things, yeah, and probably you will end up with some third-party provider to do this, because the functionality of X-ray sometimes is not sufficient. We also work with one of them, but be aware, of course, the cost of the observability is not negligible. It's really big one, so we need to think about maybe sampling and all that stuff, with the risk of losing some things. Maybe the last quote, and I found it interesting, Gregor Hoppe wrote the article Serverless Illusion in April. Now he left AWS. I hope not because of that article. But he is a well-known architect. And what he says, and I agree, serverless reduces the need for ready available ops skills. And ops skills are data center ops skills, or classical things like EC2, or you manage database on your own. But they increase demand for less ready available distributed system design skills. So what he tries to say with that is it's really hard to be a distributed system, and serverless is inherently distributed with event-driven, all that stuff. So you need good design, you need good APIs. So this is a huge investment. Sometimes we are kind of brave, we start that, we are doing that, and then we only then realize it's much more complicated than that we thought it will be. And also it happened to us. We needed to deal a lot with that. And of course, even if we are talking about serverless, yeah, we are focusing more on the business logic. What is of course true is that dealing with all that retries, all that stuff is not the business logic. Yeah, but we need to think about it in this distributed system, how the things are working, and it's also not the business logic. It's shifting the work also to some different place, I would say, just the thinking. But of course, the power of serverless that you can do everything in one team, and we are doing just this. All what I've shown you has been implemented by one team. We don't have ops. Each dev does the op part, and this is, of course, we are much more quicker with that, but it required a lot of investment in learning. And not every company can sustain this investment, to be honest. All the companies are on different stages. The things are maybe differently important. We were allowed to do this. I'm quite grateful for that, but it may not be the use case. But if you are kind of through this learning phase and you can deal with that, then you will see huge benefits. So that's basically it, what I wanted to talk, explain and show you. And thank you very much.